Okay, so here's what we did last day. We had a bag of chips which had a population distribution of 0.25 because we had 200 chips altogether and a quarter of them were red. From that, we each took a sample of 20 chips and we each made up our own calculated a proportion of how many red chips we had in that sample. And from the whole lot of samples that we did, we made a dot plot of our class estimates, and so we found the proportion to be, the mean of that proportion to be 0.323 based on our estimate. So we created a partial sampling distribution, and this is important. It's partial sampling distribution for the distribution of chip colors. The sampling distribution is the distribution of values taken by the statistic in all possible samples. Okay, that is important. All possible samples of the same size from the same population. So ours is partial because we did not get all possible samples. So example 1, Fathom software was used to simulate choosing 500 SRS of 5 cards from a standard 52 card deck. Now Fathom software is a statistical software program. Statistical software. Okay. And the graph shown to the right is the distribution of the sample median for these 50 samples. So remember, that's the middle of the numbers that we ended up getting. So if you drew a 2, 3, 5, 10, and a jack, 5 is your median. Is this a complete sampling distribution of the sample medium? So the question is it complete? And the answer is no. It is a partial sampling distribution. Because we did not take all possible samples. If we had taken all possible samples, we would have had the number of 5 card hands in the deck, which we could have found by doing 52 keys 5, which comes out to, what do we have? 2,598,000. I don't know what it is. 598,960. So 500 is definitely not going to get all of our samples. So describe the distribution. Are there any obvious outliers? So we will do socks. So S, it is symmetrical. And it is unimodal. O, there are no apparent outliers. C, where's the center? As marked, you can see that 6 is the largest value, the most common value. That's our center, 6, and that's our sample, sorry, that's an S, sample median. And S, if we look at range, it goes from 2 to 10, with most values between 4 and 8. Now, we're going to start looking at how can we use this information. So first thing we're going to do is we're going to need to be able to make some estimates of probabilities based on our histogram here. So I have gone ahead and measured out how tall each of these bars are to give us some proportion. So if we said this was 2, actually these were in millimeters, so 2 millimeters high, 5, this is just to give us proportions, and these are rough numbers, 21, 19, 15, 7, and 1, and when I add all of those up, it equals 100. So to find out the probability of being having a sample median of 4 would be 13 out of 100. So let's have a look on the next page at our questions. So in this first example, suppose another student took a different deck of cards and claimed it was exactly the same as your deck. When you took an SRS from their deck, you got a median of 4. Do you think that their deck is different from the one you used? So just a minute. Okay. So for 4, so I'm not sure if I said it the right way before, but let's have a look. In our sampling distribution, approximately 13 out of 100, or 13%, of our samples had a median of 4. So if we use this little guide, we had about 13%, which puts us in this range, more than 10%. If you've got more than 10% probability of having that median, then you shouldn't be too surprised. If it was between 5 and 10, it's kind of on the line. You can decide whether you think it's surprising or not. If it's and maybe give some reasoning behind it. If it's between 0 and 5%, then you can start being surprised at getting that result. Okay, it's pretty rare. So here, so the median of 4 is not particularly unusual. And there is no evidence his deck is different, or her deck. Okay, the admin heard all sorts of discussions in this class and came in to resolve the problem. So Mr. Crowley came in, and he took an SRS of the new card deck. He got a median value of 3 in his sample. So what can we conclude from his result? So, once again, from our distribution, and only, in our case, 5 out of 100, so we can read that right off of the histogram, or 5% of our samples so in only 5% of our samples we saw a result this small. So I would say that we are sort of on the cusp of surprised and you decide. So it's may be unlikely. So it is mostly unlikely, let's say. We conclude it is, let's say, a bit unlikely that this deck is the same. Now, Mr. Chubb did the same, and his median was 10. What can we conclude from his result? So, from our histogram, only 1 out of the 100 in a proportion, or 1%, only 1 out of 100, or 1%, of our samples had a median that was that large. Oops, sorry. Had a median this large. So this is unusual. And we conclude it is unlikely the deck is the same. The deck is the same. I would also question whether the deck that Mr. Chubb was drawing from was the same as our friend and Mr. Crowley were drawing from, since it is quite the opposite side of things.